So in this video, we'll take a look at how to interact with the mouse using LabVIEW. And from the mouse, we'll be able to get its X and Y position as well as the button information. And we will also briefly touch upon the concept of clusters. So they're actually important when you start to interact with hardware devices like this. So let's get started. So let's create a new VI. And in the front panel, I'm going to keep a chart because we want to view the time series data. And I want to keep two LEDs so that I can see the button press. So I will give two square LEDs. So I will name this left. And this will be right. Now that we're done here, we will also create a stop button to stop the VI, and we will create a numerical control to add delay because this will be running in a loop. Now we go to the block diagram. You can see all our components are here, and I'm going to create a while loop for now, and I will put all of this inside the while loop. So to access the mouse, you will actually go to connectivity, input devices, and you can see that there's an option to initialize joystick, initialize keyboard, and initialize mouse. So let's keep that outside the loop. Go back to connectivity. We need to acquire the input. So we're going with acquire. Then again, let's go back to connectivity. Close input device. So what happens is when the VI starts, this block gets executed and the data flows into this loop and into this block. And once the loop terminates, the data flows out into this block. So let's take a look. We have access info and we have button info. So in this case, this is actually a cluster. So a cluster is when you have multiple similar or dissimilar element types, that is data types, inside a single channel, right? So not a channel, basically inside a single wire. So in this case, since all are the same type, we're just going to connect it to waveform chart, right? So it accepts the cluster directly. And here, let's say you want to connect it to the button, you notice the color is different. So you can't actually connect it to the LED because if you see here, type of source is a cluster of 4 elements, type of sink is Boolean, true or false. So we can't actually do this. So we need to unbundle the cluster. So to do that, we go to clusters, unbundle by name, and we give the input there. So now you have button 1 and we just scroll down, button 2, button 3, button 4, right? So in this case, I'm just going to take 2 buttons. So button 1 is left, button 2 is right. And for the delay, we are going to give wait milliseconds. We're going to connect this, go to edit, cleanup diagram. So let's go to the front panel. Let's add a delay of 10 milliseconds per iteration, and let's give start. So notice in the chart, there are actually two data series. So we have the X as well as Y. So the white is the X-axis and the Y-axis is the red line. And this is the left and right button. So now notice that we actually have a good time series information, right? So let's say you want to plot the path of the mouse. So this is where we can use another thing called the XY graph. So you go to graph, you can go to the express XY graph, right? And we can actually plot the mouse movement here because we have both the X and Y information. So let's add one more control, which is a numeric control. This is because we will need to remember a graph needs to have segmented data. So we need to put that inside a for loop. So in this case, I'm going to go with, I'm just going to name that as loop. Let's go to the block diagram. So notice we had to unbundle the cluster for the buttons. In this case, we will need to unbundle the cluster for the axis. So I'm going to unbundle by name. I'm going to connect the axis information. So I have the horizontal, that is the X. And I have the vertical axis, that is the Y. And remember, we have to put all of this inside a loop. So let's bring all of this together. And we will put the buttons inside the loop. And remember, we have to give the count, loop count. So I'm going to do that here. So I'll go back to the front panel. I'm going to say I want the loop to run for say 100 iterations and with a delay of 10 milliseconds. So what is going to happen is every 1 second we should get an update here. So I'm just going to run. I'm going to try moving, but you see that nothing is actually happening, but the left and right is working. So this is because if we go back to the loop, you notice the output is actually, let's clean up the diagram. So you notice that the output is actually showing a loop tunnel, but the output is actually giving the last value. We don't want that. We need an indexed value. Same way, the second one, you can right click, select, right click. You want the tunnel mode to be indexing. Let's edit. Clean up the diagram. Okay, so sometimes that doesn't come, that's because something is selected. Let's go to edit, clean up diagram. Yeah, so let's go back. And just we have to make sure that this screen is actually a wide, ultra wide screen. So I have cropped it here to 1080, right? So our x-axis is actually 1920 and 1080. Right, so actually the screens, this screen's true resolution is higher than 1920, but that is at the edge of this window. So I'm just going to move the mouse within that range. If I'm not moving the mouse now, it is going to be at that position. But notice again, the auto scale has stopped us from viewing the actual position. So let's take off auto scale in both cases. So this is going to be 0, 0. So this will be 1080 and this will be 1920. So let's just leave the mouse there. You can see that there is a dot. So I'm just going to keep moving the mouse like this. So you see that the information is actually being captured. And if I reduce the delay in the loop, you can actually create something more of a real-time function. But you notice that when I move the mouse up, it's actually moving down. So this is because the origin point for the graph is the bottom left and the origin point for the monitor is actually the top left, right? So this can just be inverted in software. So let's say I want to get the mouse position in real time. So unfortunately, you can't use just for one iteration because remember, it is not a segment, it becomes a single quantity. So you need a minimum of 2 iterations. And when I do that, you can see that it is actually following the mouse pointer in almost real time. So again, the left right is correct, but the top down is inverted. So in this video, we saw how to interact with a mouse using LabVIEW. We were able to get the X and Y information as well as the button information. And in the next video, we will take a look at how to interact with a joystick using LabVIEW. Okay, so until then, take care.